Dirt, soil. It's pretty ubiquitous wherever you go, and everyone has had some sort of experience with it. But what really is soil? What is it made of, and where does it come from? There are two very distinct types of soil: organic and inorganic soils. Organic soils arise from the decay of organisms. They are typically dark in color and rich in plant nutrients. You'll likely find organic soils near the surface of most soils that support plant life. Organic soils will continue to decompose away, which is why large buildups of organic soil are typically found in wetlands and regions that sustain a cold enough winter to slow decay. Inorganic soils are known as mineral soils. They are typically lighter in color when dry than organic soils, and they result from extensive weathering of bedrock by the 5 soil-forming factors, eventually forming the 3 main constituents of mineral soils: sand, silt, and clay. The 5 soil-forming factors are 1. Parent material. In mineral soils, this would be large, unconsolidated, fragmented bedrock. 2. Climate, including temperature, strain, and precipitation. 3. Topography, relating to the slope and gradient of the land the soil is forming on. 4. Time, which may be thousands of years of which the soils are exposed to weathering. And 5. Biota, being the influence imposed by living organisms. There are 3 common types of weathering that can break down rocks. They include physical weathering, chemical weathering, and biological weathering. An example of physical weathering could be a rock falling down a hill and breaking into pieces. In this example, we shatter a piece of limestone. Physical weathering of rocks increases the surface area, allowing for faster weathering from other sources. An example of chemical weathering would be acid rain, where acid presence in rainwater reacts with the rock's surface, causing it to dissolve. This effect can be compounded by geologic and human industrial activity that increases the amount of CO2 and sulfur dioxide in the atmosphere, which dissolves into rainwater, causing it to become acidic. In this example, we simulate acid rain by pouring 5% acid vinegar over our rock fragments from the previous demonstration. The calcium compounds in the rock react with the acid and dissolve, causing the fizzling seen in the video. This time lapse spans 3 hours. Shattering the rock increased the surface area for the acid to react with, though if I would have used a more concentrated acid, more chemical weathering could have been observed. Biological weathering is either physical or chemical weathering resulting from direct influence of living organisms. This would include plant roots growing into cracks of rocks, expanding and further weathering the rock, as well as chemicals that plant roots can extrude, corroding the rock and making it brittle and more easy to penetrate. You now had a brief introduction on what soil is and how it is formed. In following videos, we will explore the importance of soils, their various uses, and why soil conservation is paramount to humanity's continued ability to thrive on Earth.